This is Echo, a giant metal balloon launched by NASA in the 1960s. Known as the most beautiful satellite ever launched, it had no electronics and simply bounced radio signals around the world using its reflective surface. Despite its simplicity, it worked extremely well. But how did this actually work? In the same way that light bounces off a mirror, radio waves can also be reflected. As the signal is bounced off the surface, it spreads out in every direction. A small portion of the signal will make its way back to Earth, where it can be picked up by a receiver in a different location. A larger reflector will return a stronger and more focused signal. And so, in order for these balloons to work, they had to be absolutely massive. Echo 1 was made from a giant sheet of mylar plastic, 1/10 the thickness of a human hair. The sheet was cut up into over 100 gores, which were each covered in a thin layer of aluminum to give the balloon its shiny surface. The gores were then glued together to create the final sphere. This would be by far the biggest thing ever launched into space, and the only way it would get there was by packing it down and inflating it once it was in orbit. But this proved to be a massive challenge. Without its own air supply, how did Echo actually inflate itself? In order to turn Echo from this into this, it needed to inflate itself in space. Instead of carrying its own air, the balloon had small canisters of benzoic acid, a special powder that turns straight from a solid into a gas when exposed to heat. And so, when the balloon was released into space, the heat from the sun would quickly turn it into gas, causing it to expand inside the balloon. In just a matter of seconds, this enormous balloon would be fully inflated. Of course, these giant shiny balloons ended up being extremely visible, but this brightness was actually a key feature. In order to actually send and receive signals, the ground stations had to be able to track and lock onto the balloon as it moved across the sky. And so the easiest way was to simply point the antenna dish directly at the balloon when it was visible. Of course, this was only possible when the balloon happened to be over that part of the Earth, and only during twilight hours when the sun was illuminating the balloons. If the balloons couldn't be seen with the naked eye, they could rely on NASA's tracking network, which did its best to predict the orbits of satellites. On Echo 2, they included a tracking beacon, which sent out a pulse and made the balloon much easier to track during the day. But the balloons weren't just useful for sending signals around the world. They were also used to accurately measure the size and shape of Earth. At the time, our most accurate measurements relied on star triangulation, which meant that the actual distances between continents and cities could be off by over 100 kilometers. And so scientists used Echo to map the exact location of various points all around Earth. Then, by measuring the angle that Echo appeared in the sky, the scientists could form a triangle. With this, the distance between both points could be calculated to within a few meters. This made our measurements of the Earth around 10 times more accurate. These two balloons continued to work perfectly throughout the 60s, and they proved that a global communication system in space was a good idea. During their time in space, these iconic balloons taught NASA more than they could ever have imagined. The receiver that was used to detect Echo's signal went on to discover the Big Bang. The materials developed for Echo are still used in spacecraft to this day. Although these types of satellites never caught on, their legacy as the first leap into space communications will live on forever. And Echo 1 and 2 will go down as the most beautiful satellites ever made.